Hi everyone, and welcome to Stump Jen. As usual, we got a ragtag mob of us here today. I have with me today Jenny Morgan. Hey Jen. Got Sam Chaos.
Hello there.
We got Chadwick Hall. Hi Chad.
How's she going?
Goodly. And we got Jeff, the Godless Scammer.
Ahoy.
What was the pointing for? Hi to everyone in the chat. There's not too many of you yet. Hopefully a few more will drop in, but it is a weird time of day, I guess.
Yes.
So yeah, how are we all? Are our brains all
in-
functional?
I'm interested in Jeff's choice of ahoy.
Oh, hoi hoi.
I don't know. I was doing oi oi a few months ago, and I just changed it to ahoy for some reason.
So you're trying to
Ahoy.
follow Plane of Walk,
That's-
are you there with the...
Ahoy is how
Maybe-
Alexander Graham Bell tried to get people to answer the phone when he first.
Oh, it is, isn't it?
I
No,
was
that's-
just going to say, yeah.
And it
Ahoy,
didn't,
hoy.
it didn't catch, thank God.
Well, that's why they made that one joke in The Simpsons that one time. The only time Mr. Burns ever answers the phone, he goes ahoy, hoy.
That's...
It was mainly I said oi oi, but then every time that would be on Dave's show, Jenny would be on there, and then she'd do the same thing and add an extra oi.
Oi, oi, oi.
Yeah.
Yeah, it's not like someone just shouted "Oggy, Oggy, Oggy."
That's,
Oh, yeah.
I do that as an homage to what's his name, Jut Monk.
Yeah.
Oh yeah, the drunk monkey.
Oh yeah, he does
Yeah.
that. He does oi fucking oi, doesn't he?
Oi, 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 fucking oi.
Well, yeah. I don't use words like that myself.
Of course not.
No. Mm-mm.
Well, shall we start with something? Okay. So there's a new study from a trio of European researchers that have decided that there's that out of the equations it suggests that at the beginning of the universe, where you've got primordial black holes forming, we would also have what was called stupendously large black holes, and black holes, we're measuring it in billions of times the mass of the sun, some of the really large supermassive black holes, and now we're talking about ones that could be, a black hole which is almost which is a decent proportion of a galaxy's actual mass. And they think these things could actually exist because you had so much matter close together early on, and the uneven distribution of matter during the expansion of the universe are slightly uneven, not completely uneven. That it's quite possible we could have ended up with these stupendously large black holes out there, and you wouldn't form galaxies around them because they would effectively just clear everything in their path. And will we even be able to see one if it came towards us?
You see, I love this stuff, but I also find it boring in a very strange way.
It is, isn't it?
Because when you're talking about black holes, it's always talking about the categories. And when you're talking about, say, primordial black holes, like what happens if the sun turns into a black hole, and those kind of hypothetical, supermassive, stupendously large, at the end of the day, if you can imagine a configuration of matter, it's out there in the universe. Like, it's a pretty damn big place.
Oh yeah.
So the idea of having a lot of shit in one spot really doesn't surprise me, and yet every single week, astronomers are basically saying there's bigger shit, and I'm like, no, really. It's like, it's getting kind of obvious.
Well, yeah, it kind of makes sense, but they also don't think that these things could actually form from mergers of black holes. They think they would have had to have formed primordially. I tend to disagree with that. I can see no logical reason why you couldn't actually have a stupendously large black hole form at some point. It would tend to make sense that, I know there's concepts of with large enough objects as they get into close orbit, there is actually more chance that they'll throw each other off in different directions and them actually combining. But there's still a chance they will combine. And there's always a three-body problem.
Yeah.
In that.
I mean, it might be that That combined with the factor that as stuff is moving further and further apart, the odds of a collision reduce.
Yeah, but when you say further,
simply the
when
case
you say further and further apart, you got to be careful though, because when you say further and further apart, from what? I mean, yes, it's getting further from us, but it's getting closer to the shit that's over there coming towards us, right? So it's more or less uniform density in the universe. You got to kind of balance things out a bit.
Not completely uniform.
Not to be
The
pedantic,
universe
but
is
it's one of
not
those subtle
completely
things.
uniform.
Not completely, but you know.
Even the
close enough to
expansion of the
refuse. And
universe
universes-
isn't completely uniform. We know that certain parts of the universe are expanding at different rates than others. So,
see, now that's interesting to me. I have not heard that one.
haven't you? Oh God!
Now,
this
relative
paper
to
only
me,
came
I
out
know
about
that
4
there's
months
different
ago.
expansion rates.
Okay.
Now we're talking. Let's talk.
Yeah, and I honestly cannot remember who were the authors for this one. I'm so sorry.
At all. It all writes everything. Don't worry about it.
I'll look it up. I've stumped myself.
You've never heard at all? He writes all these things. It's always like John Smith, Tim Brown, et al. Et al's on all these papers.
May I have a question?
Yeah.
Jeff, did you know that if you mix vinegar and baking soda, it foams up and gets all bubbly and stuff?
Oh, I didn't know that. I think I might have to do that for an experiment.
Yeah, I was thinking I should try that too.
Yeah.
Okay, so the first the study lead author was
I was going to get deeper into that, but anyways.
Constantius Magogus of the University of Bonn in Germany. So the paper comes out of Germany. It was first talked about in April of last year, but it was only published about 4 months ago. So, but basically, they
it
went
observational or is it a?
It's observational. They went back through a whole heap of observations about red shifts and blue shifts of stars, as well as studies on the cosmic background radiation, and they figured out that different parts of the universe are expanding at different rates.
I am going to answer one question someone's asked in the chat.
Go for
Yes, Dave. Yes, you are. You know this already. You were meant to keep ketchup in the fridge.
I disagree, but that's just me.
Sanitation reasons.
Yeah.
Sanitation.
You probably put your toilet paper on the wrong way too, do you?
Okay.
It probably is going to end up as the next pineapple on pizza.
So Sammy has a
discussion, isn't
question for us. What's the furthest we have ever shot a laser? It would depend on when the first time it was that we actually deliberately shot a high-powered laser into space.
It doesn't have to be high-powered because I mean, strictly speaking, a couple of photons is enough. So
yes, it would be very divergent though.
Yeah,
at that point. Although I say that, I will correct myself and say most lasers diverge at approximately the same rate, so it's not more divergent. There's just less intensity of light. All
right, I'm going to introduce you guys to a nonlinear optical phenomena known as self-focusing. Have you heard of this before?
Self-focusing?
Essentially, when you're self-focusing.
Okay.
So when you have a laser traveling through a medium, regardless of what the medium is, even if it's free space, but the properties are a little bit different there. It's easier to think about in the atmosphere. If you have a laser that's traveling through any kind of medium, if that laser is strong enough, the electric field from the laser itself modifies the dielectric materials of the whatever it's going through, basically turning the atmosphere or whatever it's going to into a lens, which is to say that if a laser is strong enough, it will focus itself as it goes.
So it will diverge less with a strong enough laser.
No, it will not diverge.
It will not diverge. Okay.
It will not diverge. It self-focuses.
I mean, I realize space isn't a true vacuum, but
phenomenon.
surely the degree of vacuum in space would be enough that effect would be very minimal.
It would be very minimal, yeah, but I mean...
So you're still going to have divergent...
If you had so you'd have to have a really fucking strong laser, but in theory.
Yeah.
Well,
I
yeah,
think
but I mean,
I think Dave might have the answer to this question. He says Alderaan.
Well, that was just a very
Well,
intense.
what difference
we're
does
allowed
that
being
make
educational
to
on
us?
this show.
Yeah.
Well,
If we're
actually, I'd like.
shooting
Yeah, we're allowed
lasers-
to, but I'd also like to point out that the Death Star did not use lasers. You cannot combine lasers in the way that the Death Star shoots its main gun,
Yeah.
so it cannot be lasers.
So if
And
we're shooting
most of the
lasers
other
on
weapons in
outer
Star
space-
Wars are plasma based, not lasers.
To
Oh,
be honest,
sorry,
I know
lasers are
Star
kind
Wars crap.
I'm no expert in like physics or whatever, but I do know the physics in the Star Wars universe are complete bollocks.
I will say, as far as physics go, when it comes to lasers, I actually am an expert that was doing my graduate work on this stuff. So this is something I know a fair amount about.
Okay, now
I'm
if
really
we're
excited
shooting,
to talk about lasers.
Chad, if we're shooting lasers through space and all, and what you say about going through a medium is true, and I have no reason to doubt you. What benefits does that give us? Because space is not an ether; it's an emptiness.
Mm-hmm.
So what would be? There wouldn't be anything out there
Well,
for us to
Space
through
isn't
the-
empty though, Jenny.
I'm going to change your worldview a little bit. I'm gonna try and change your worldview a little bit. The ether, as it was understood by Michelson Morley, does not exist. The ether has been replaced with a concept of space-time. Stuff still travels through it, but it's the same concept. We have this idea of stuff that travels through things at different rates depending on what fields are around it. It's there, but it's not what we thought it was. So we don't use that name. But it's kind of the same concept. It's
Okay,
like,
so
oh no, it's not actually. It's not actually ether.
Is it going through? Is it going through space time and that stuff around it? Then is a force.
Are you talking about the self-focusing, the laser stuff?
Yeah. Uh-huh.
Okay. So getting back to how lasers work, if I can, the reason why light even goes is because it makes itself. So this idea of a self-focusing laser isn't a strange thing. Let me explain that concept. When you're talking about light, we talk about it as a photon, but what is this little chunk of whatever? Well, if you look at Maxwell's equations, which is basically a set of equations that basically say this is how electric and magnetic fields wiggle. If you have an electric field wiggling up and down, that'll cause a magnetic field to wiggle back and forth. But that magnetic field that you just made that's going back and forth, well, that actually causes an electric field. And you have these two things feeding off of each other, which allows electromagnetic radiation to exist as its own thing. It doesn't have to be part of something. So you have to kind of think of this ethereal, when you think of space-time, everything in our universe is kind of pinned to that in some sense. So we're kind of exploring the properties of the ether as opposed to saying, let's just straight get rid of it. Because space itself has electromagnetic properties. We can measure them. That's the electric permittivity and permeability of free space with the Greek letters with the little zeros below them.
I mean, at the
I mean, you
quantum
can get
level,
technical if you
everything's
want,
described in fields anyway. To a certain
Well,
extent.
that's just yeah. And it's kind of like saying, physics is applied chemistry, chemistry is what is it? Biology is applied chemistry, chemistry is applied physics. It's kind of that sort of thing. At the end of the day, it's all fields, but my brain doesn't work well when I try to imagine nothing jiggling. So it's easier for my brain to abstract that to something like, hey, I have a particle that moves. A particle's not really a thing. It's an idea that we have that represents what's out there.
And
So
is that
it's a
not
very
where the
subtle
concept? Is that not where the concept of virtual particles come from?
Virtual particles are actually something interesting because I'm sure you've heard of the Heisenberg uncertainty principle, right?
Yep.
It's this thing that basically says the uncertainty in displacement and the uncertainty in momentum multiplied together are going to be less than or equal to, has to be greater than or equal to h bar over 2, or whatever the number is. I think it's h bar over 2.
Yeah, no, you're right.
There's a second one that people don't talk about in terms of the conservation laws. In terms of these uncertainty principles. The first one is between space and momentum. The one people don't talk about is between time and energy. So when you're talking about things in the nuclear world, essentially you have this uncertainty between energy and time, which is to say that if you take energy and time, multiply them together, or the uncertainty in energy and the uncertainty in time, and multiply those things together, it's always going to be greater than some number. So it turns out that because time is like this strange thing, and what does it even mean to talk about uncertainty in time? Like, then your brain starts to go, what the hell's going on with quantum mechanics? Put that aside for now. The fact that time is something you can have a little bit of or take a little bit away of is kind of an interesting thing quantum mechanically. What this second uncertainty principle essentially means is, for a very short period of time, delta t, you can borrow a lot of energy, delta E. Because those two, a big thing multiplied by a really little thing, can still be a little number.
It's actually one of the concepts that allows the universe to exist.
Exactly. It's this idea that when you talk about something coming from nothing, well, people don't think about time as something that jiggles and is fundamentally uncertain.
Yeah. Well,
but at the end of the day, time is and this is the kind of conversation I would get into with Steve, where I would say time is ultimately a concept that represents our understanding about how this aspect of our universal dimension works. Time isn't an arrow as he understands it, so you have to start being very careful and pedantic when you start getting down to this basic level.
If you're looking at the underlying structure, which is the quantum nature of the universe, which is quite possibly quite possibly eternal. I'll go with eternal. Yeah. It's always been here and it will always be here. But our universe that sits on top of that is finite. You put a finite thing and divide it by an infinite thing, you end up with a stupidly tiny, almost non-existent number. You know,
infinitesimal.
An infinitesimal. So our universe can exist just because effectively it doesn't exist. So in the scheme of things, as far as there actually being an excess of energy or anything, if you've got an infinite amount of time to borrow these tiny little improbabilities from to create a universe within, you can easily have a universe right now. But over the stretch of infinity, there is nothing. There is a net zero energy to the universe.
According to current models, yes.
Yeah.
Yeah, I was about to say all of this needs to be couched in according to
current models. Yes, yes. We could find out new things in physics, and we will find out new things in physics, and that could totally change our image of it. But this is the concept where you can have something come from nothing. Essentially, we just basically live in a little pocket that's slightly more than nothing.
Well, here's the thing. Like, if our entire universe,
say the thing you said earlier about energy. When I asked about, is it a force that's keeping this focus thing going?
Okay. So you know how if you take like what a regular lens looks like, right? It's kind of thicker in the middle, thin on the edges, right? And that focuses things. Yeah. The reason why that works is because when light is traveling through that lens, it has to travel through more thick stuff in the middle and less stuff on the outside. And if you think about light traveling at speed, well, when it hits that medium, it slows down. Well, imagine trying to slap somebody with your hand, and then suddenly you hit something hits the middle of your hand. Well, your hand bends around it, right? I mean, that's just kind of what happens. Sorry, I should probably use my camera for this one. So if you have something that's doing that, when something bends into it, it's going to kind of wrap around a little bit like that, right? So essentially the same thing's happening with the self-focusing phenomena. Because there's some medium, some stuff that's the light is traveling through.
Yeah.
The light changes the thing that it's traveling through because it's an electric field and it has to move electrons around and cause stuff to jiggle and matter. I mean, this is how stuff works, right? So the light smashes into this thing. It slows down in a traditional lens and kind of comes to a focus. The way self-focusing works is this plane wave is coming along. But because it's so intense, the intensity is usually higher in the middle, and then it kind of dissipates out. Well, the stuff on the outside is just going to scatter. But there's a certain threshold where above a certain intensity, that light, the disturbance in the material that the light itself is causing, causes the material to work like a lens. If you want to look this up,
See, when you talk about it that way, it makes me think
it makes sense.
That
Yeah,
you've got
it's all
this
about the
thing
Huygens
being
principle at the end of the day.
going through this media, and the media is acting like I visualize it in terms of fluid dynamics. You know, that the
Yep.
weight it's coming back
That's a good way to think
itself,
about it.
and it's concentrating things
Yes.
down, and
Exactly.
and that's why I think it's a force.
The vacuum of space isn't a true vacuum, is the thing to remember here, I think.
Well, yeah, I know that.
Yeah, I understand your
Now-
hesitation there, because you're using the word force when what you're trying to say is a tendency to do a thing, and that tendency to do a thing is is basically the last 20 minutes that I've been talking. So it punks a lot in there.
Okay. Now, how does
but you're not wrong. Yeah,
follow then? If we think of a laser as a very powerful, concentrated beam of light that is.
Just for a moment.
It's cohesive. What?
Well, I was just going to be strict in the definitions. A laser is coherent light.
Coherent, yeah.
The intensity of the light bulb is entirely up to what wattage. But anyways.
Right. And so it's doing this thing, and it's going to but these lasers that we have still can't go very far. I mean, they can bounce off the moon. We do that, but they bounced one off of Mars.
No, that's not true, Jenny. We've sent laser messages to other stars. High impulse lasers through telescopes.
Now,
how do we know?
Chad
that?
and I-
we don't know if they got there or if they got picked up at the other end. Not yet.
Okay.
Anyway,
See, now
but-
that
I will say
my next curiosity is when we look out into the deep field, like for Hubble, and we see these galaxies that are just beyond belief of distant away. How is it possible that those photons could be getting to us at all?
Oh, I've got a treat for you. Okay, you ready for this?
Sure.
Current models, universe is infinite. You're good. You're cool with that?
Yep.
Let's just assume universe is infinite in all directions. Big Bang means our local space-time is now bigger relative to what it used to be. That's all Big Bang means.
Yeah.
The thing is,
The Big Bang is only relevant to our observable universe. Basically.
the big. Okay.
As far as we know,
what
it's
I-
only relevant. We can only know that it's relevant to us. It could be more relevant to the rest of the universe, but we only know it's relevant to us.
yeah.
Sorry, I got distracted. What was your question again, Jenny? No, it's okay. I got myself distracted.
My question.
How can photons even reach us? Was the
Okay.
thing.
Oh, was it photons? Okay, two things about that. The first answer, well, that was the first question she asked, and there was the second one. The answer to the first question is yes, we've shot lasers to the moon and got them back. No, we haven't shot them to Mars, but we did use Arecibo as a radar detection station for asteroids. So we have seen things further than the moon using stuff that we've shot from Earth. So that's kind of the answer from the first question.
Yeah.
The second one, I got derailed on.
How does
so
the light
exciting.
from far galaxies get to us?
Yes. Okay, so we have this idea that the universe is expanding, right?
Mm-hmm.
I'm just making sure we're all okay on step by step. I'm going to exist right here in the middle of me. It's a pretty sensible place for me to be. And there's going to be a star that's kind of hanging out right here. And it's going to start, let's see if I can figure my frames a little better. I'm going to use this hand. So, and this is going to be a little star. And the star is, think about it, it's according to space-time. Let's just assume that it's stuck there. It's pinned in space. It's stuck to space-time.
Okay.
So the only motion it has relative to me is that it's expanding away with space-time. It's going with the current.
Yeah.
Right? So again, this idea of fluid dynamics you have is actually really good. Now, the further away you get from me, the stronger that current gets, the faster things seem to be moving away, which is where we get this idea of universal acceleration from. Yeah? We're all good so far? Here's the part that's going to hurt your brain. If this star is a certain distance away from me, let's say approximately 13.6 billion light years away from me.
Okay.
The light from that star if you were thinking about it as go back to this fluid dynamic thing, the light from that star is a fish that has to kind of travel at the speed of light to get to me. So it's got to swim at the speed of light and slap me in the face, and then I see it. There's going to be a point where the speed of light, the fish swimming this way, the light traveling towards me, where was I? The light traveling towards me is moving away at the same speed because of the current, the expansion of the universe at the speed of light.
Mm-hmm.
So relative to my frame of reference right now, there's a photon that I can point to in any direction that's traveling towards me right now that is essentially frozen in space.
Okay, but I can still see the. I can still see the photon.
No.
Oh no,
not
you
if it
can't
hasn't
see
got to you.
No, that photon never gets to you. The fish never slaps you in the face.
But if I can
fish
see
is
it,
coming, but you're never going to see it. What's that, sorry?
If I can see the photon, it is getting to me.
Yes.
But your own. What I'm saying is you only see the fish you see. I'm saying there's more fish out there. There's a weird spot in the universe where the light's coming at you and there are fish coming at you that are never going to slap you in the face. There's a photon heading straight for my eyeball that will never get there.
If it wasn't for the expansion of the universe, the sky would be bright in every direction.
Yeah, and this is essentially why you're getting into Olber's paradox.
Yeah.
Wait, there's blood coming out of here. Okay,
well,
continue.
Olber's
all right, so
Olber's
even with the
paradox
light that can get to
basically
us, Jenny, that's close enough that, and within the, which has happened in soon enough ago that it had enough time to get to us. Most of that is blue shifted so far that we can't see it.
And was close enough.
Yeah,
And
because a lot of the light that's a lot further away is so far blue shifted that our eyes don't see it, the sky is not just awash with light. That is the only reason why. But if you look up at the sky in the ultraviolet, or in higher way, I've done that the right way around, haven't I? Yeah. You will see that it is in fact incredibly bright. The sky is incredibly bright because there are basically stars and galaxies everywhere, but some of them are so blue shifted we can't see them. The light that when a photon leaves, unless of course it actually interacts with something that stops it, it will keep going forever. And even sometimes if it does interact, like if it hits like a gas particle on the way, it will put some energy into that gas particle, but that gas particle will eventually release that again, and you end up with a new photon, basically heading in the same direction. So photons, unless of course they come up against something solid and are reflected, keep going forever.
Yeah, like I said, the photon itself travels through the ether, which we now call space-time. Yeah. Ether does exist, it just doesn't have the properties we thought it did. It turns out the ether is stuck fixed in space and has properties, namely light travels at the speed of light through it, things like this.
Now when it hits this this gas thing that you're talking about there, I'm visualizing a billiard table, and I ball into another, and if I don't hit it dead nuts on center, it's going to go off some different direction.
Okay,
and as Newton would predict.
There's two things happening here. First, the universe is incredibly empty unless there's shit in the way. That is to say, unless there's like a rock or a sun between you and me, there's likely not a whole lot of particles between me and a photon from any given star.
Yeah,
I mean, yes, there's stuff, but based on the sheer volume.
And stars emit an immense amount of light, and galaxies more so.
Exactly, and we
only get a small number of those photons from very distant galaxies that actually get to us. But there are billions upon billions, trillions of photons that are emitted all the time from those galaxies, and we get a handful of them.
Here's a lot of people get freaked out by this, but most people don't consider the photon that just traveled here, that just traveled here. I mean, there's lots of photons that I can't see. If I move my head over here, then I can suddenly see, oh yeah, there were in fact blue photons coming in this direction because my eye can see them. They're still there. Like, there's still blue photons here that I can pinch. They're just not hitting my eyeball. I mean, people need to... There's no intent when physics is happening.
Yeah.
So when you have this idea of a photon coming in and hitting a billiard ball, this is where we kind of have to start playing the self-focusing thing, particles don't really exist game. Because what we have is an electromagnetic disturbance coming in. And we have an electromagnetic system. Namely, it has a positive charge, a proton in the middle, and some electrons doing its thing. That creates an electromagnetic field around this thing. Well, as this thing's coming in the same way a billiard ball and a billiard ball will interact, so will a electromagnetic and electromagnetic field, or I should say electromagnetic field and electromagnetic system. The photon doesn't necessarily have to be absorbed. These things can just be deflected through partial interactions.
Yeah.
When you're starting to get into a lot of different, what's called scattering theory, and there are many, many ways that particles can interact. We call it scattering because we think about particle accelerators. We have a target here, and we shoot shit at it.
And also remember that a photon is incredibly tiny, and atoms have a lot of empty space. So even just to hit the atom, a singular atom is actually...
Yeah. So, I mean, whether or not you think about it as a singular, you can either think of it as a Roman legion. I mean, Jeff will love this one. You can either think about it as individual photons moving forward, or you can think of it as a wave moving forward. Both work. It's just a question of what question are you asking in terms of which model's better. The answer is both. It's not a particle. It's not a wave. Yes.
Yeah, I always balance that argument.
Particle wave. It's not just
a lot of that concept of particle and waves come down to us liking
categories. That's a personal problem.
Yeah.
Using good shit at brain can do.
I always resolve the argument between particle or wave that the wave is made up of particles.
Well, that would be kind of like pilot wave theory. That's...
Yeah. Is Chad frozen?
Yeah, Chad's frozen for now. Ah, here he is. He's sort of moving. But yeah, the thing about particle, the duality of matter that is generally fairly hard for us to comprehend is we live in a world of matter. Well, we perceive our world as a world of matter, but in actual fact, we live in a universe of energy. So everything is energy.
Yeah, so when people see E equals mc squared, they think Einstein relativity. Fun fact, it has nothing to do with relativity.
No, it doesn't.
What he's giving you is the exchange. What he's giving you is the exchange rate. If you have 1 kilogram of stuff, I will give you c squared amount of energy. Just go ahead and multiply them together. This is the exchange rate between energy and mass. So mass is kind of congealed energy in some sense.
Yeah.
You can break it apart and use that energy for other things. There are conservation laws that describe how matter seems to do that.
You could basically look on matter as
standard model of nuclear physics.
You slow down water molecules enough and they turn into ice.
Yeah, you're basically looking at a way to think of it is like condensed pockets of energy within space-time.
Yeah, and you think, well, I wouldn't so much go with the water ice analogy, Jenny. Sorry to interrupt you, Sam. I would go with not with water and ice. What would I say?
Yeah, I don't know where you're going with this.
Oh, sorry. I had a thing, but then I felt rude, and I apologized to Sam, and I derailed myself. Anyway, sorry.
Olive oil and bruschetta?
Talk amongst yourselves.
All right, well, so we had a history question for Jeff, so shall we get off physics and let Jeff have a history question?
I was wanting to ask Chad a physics question, I think. A minute, so
okay,
come back to that.
Go on, Sam.
So the thing with the self-focusing, I'm half remembering something. Is it that it will actually slowly dissipate over time because it's only a probability thing? I'm trying to remember now. I'm sure I read something on this.
No. When you're dealing with light, if you know what a normal distribution is?
Yep.
Hold on, I'm breaking up here.
Oh, we heard you.
So if you know what a normal distribution is, it's okay. It's this kind of, it's that curve where it's got that nice big bump and then kind of trail sides, right? Well, I don't suggest you do this. Look directly into the beam laser. You shine it right in your eye. What you'll find is what's called that. You'll see that normal distribution. We call it a Gaussian
For about a
distribution
second.
in physics. But it basically means that it's brighter in the middle. That's going to be
Brighter in the middle than the outer edge. Yeah.
Yeah.
yeah, exactly. That's another story, but I'll tell you that one later.
So what was this? What was this one for me, Jen?
But
It was
essentially-
from One Ring. It was about the first congresswoman in the US.
What was specifically?
He wanted,
Jeanette Rankin, I think her name was.
and he wanted to know what state as well. I think
That'd be Ring State. I think Montana.
Montana. Okay, cool.
Yeah. I think that she's Montana. I'm guessing that because that's where Ring's from anyway. So we lost Chad.
We've lost Chad. He'll be back.
He's starting a junk shop a little anyway.
Yeah, he
That's
was.
going to be known. That's going to be renamed Chadding before long. You do know this.
See, yes, Montana. Yep, you're right.
Okay, well, I've asked my limit of questions. Now it's your guys' turn.
Did we have any other questions that I missed? Is a photon smaller than Trump's brain? I'll get. Neurons are
pass.
neurons are larger than photons, so he'd have to at least have a couple of neurons.
We got to get Chad in there to answer this one. I think that's a very difficult question. Who's this Trump fellow anyway? I think I've heard
who's
of
this
him.
Trump? Wasn't he a president years ago?
Some used car salesman.
He's got salesman.
I'm sure I heard about him in that one movie, Home Alone 2.
Yeah.
Oh, yeah,
the
he
new
was the
Chad
guy
picture.
There we go. Let's ask Chad that
The
question then.
janitor.
Well, is Trump's brain smaller than a photon?
Be honest.
You're buzzing a bit there, Chad.
It's got bees.
Oh,
Good.
hold on. Chad, this is how you sound right now. Exterminate!
My Wi-Fi sucks.
Oh, that is really lagged.
Oh.
Yeah, he was saying something about his Wi-Fi, so I'm presuming he's just saying his Wi-Fi's fucked up.
Oh, okay.
It's a pain I know all too well.
Yours does it all the time, doesn't it?
Oh.
Alright, well, shall we talk about Simon Fraser
Right,
University
that's,
researchers?
by the way, I think that's the question Sam's best qualified to answer.
Which
what
one?
The one Rings just put in the chat.
Mommy, I just chipped a nail.
Okay, well, what in D&D 5th edition, what race class combo will give you the highest armor class without wearing armor?
Presuming you mean a level 1 variant human barbarian.
Yeah?
By the way, Sammy, I think we had this question last week. That's the Mongol Empire. I just saw Sammy's question. I'm pretty sure we had that question last week.
Yep. Unless Ring is also accepting Unearthed Arcana, in which case I'm not certain because I don't keep up with Unearthed Arcana.
Ah, okay. Wouldn't orcs be more likely to have higher armor class, natural armor class, though?
So, orcs are a thing.
Because you can have an orc as a character. So
Yeah, I'd have to check the Dungeon Master's Guide as to the actual stats for what an orc do. Yes, we can hear you now, Chad.
we can hear you, Chad. So possibly an orc
Can we?
barbarian or isn't there a thing where you can be a part dragon as a character class as well?
Yes, you can be a Dragonborn,
Yeah.
which will give you resistance to certain types of damage, but not higher armor class.
Oh, okay, because it's purely about armor class. Yeah. So an orc or dwarves have higher natural armor class as well, don't they?
Yeah. So the thing with Ring's question is that there are two classes that are not Unearthed Arcana that give you unarmored defense, so defense without armor, which would be Monk and Barbarian. And so I would personally go with Barbarian of the two of them.
And then it's just whatever race you're going to be to give yourself the extra boost with your armor class.
Yeah, which should really, I would argue, be the variant human, simply because it lets you take a feat which you can use to increase one of your stats and get additional bonuses. So that's my preference for it. But if you then want to multi-class, you can do stuff including taking a level in Cleric to be able to cast Shield, taking a feat that increases your armor class when you block. Once per turn, you can effectively block a melee attack to add 4 to your armor class. There's various things you can do to increase it.
Turtle Blade Singer.
Oh, can the Turtles be Blade Singers now? Is that a thing?
Fair
Okay,
enough.
I didn't realise that one. That's a new one on me.
Oh, there's fireworks going on outside. I can hear them. I don't know why there's fireworks going on outside. Cool. So, Chad, the question that was asked before, would Trump's brain be smaller than a photon?
No.
That was my argument too.
Oh. See what you did again. My God, audio.
Okay, it may not be smaller,
you-
but it certainly isn't as sophisticated.
Is it less sophisticated than a photon?
Chad, you're breaking.
It's certainly slower than a photon.
Oh yeah,
Yeah.
slower than a fart.
A farton is travelling faster than the speed of fart. Sorry. Bad joke.
No, wouldn't it be fun to meet Trump in a restaurant and walk up next to him and fart and then look at him and blame him?
You'd have to be good at
No,
the silent
no,
but deadly
no,
there,
no.
Jen.
I have the best farts. Nobody farts like I do. My farts don't
So
stink.
what is the most number of sides a fair die can have? There's one for you guys. Because this is what I
Fair
happen to know.
die. Ah.
I have no idea. That's
The most
I don't
number
even
of sides.
What the hell you're talking about is?
is that a D&D reference again?
No, what?
No,
No.
this one actually isn't really D&D.
Oh, we're gonna have two Chads.
Chad.
Yeah, Chad.
I have no idea. I'm actually stumped on that one. I've got to admit.
I'm thinking I should make some breakfast.
This is the last time I'm trying this phone.
That's odd. It's going weird for me. Hang on, I'm gonna remove you and put you back in, Chad. That's better. Now people can see you. Yeah, we could hear you, Chad, for a sec.
We heard you for a sec. I can't
Yeah, so
hear him at all now, but if he's talking,
That's
I
an
don't know.
interesting question there, Dornopet. Does a pork sandwich fart smell travel faster than a cabbage fart smell? No.
I think for experiment, we might have to try it for experimental purposes to find this one out.
So one of us will eat a pork sandwich, the other will have eat some cabbage, and then we'll tie Doorknob Head to a chair, and then you just fart in his general direction.
And then someone will have a pork and cabbage sandwich just to.
There's a control.
Yeah.
Yep. And then someone will have neither.
I would think that the cabbage would be much faster. It's cabbage produces more fart potential, has much higher fart potential than a pork chop.
Sammy just asked us, what happens to a photon when it loses all its energy? Photons don't lose energy.
No,
Yeah,
that's
that last
not
It's a
thing.
fundamental particle. It is at the level
Yep.
it is.
So the answer to the die question, by the way, is 120 sides.
Okay. So why is it unfair beyond that?
Because it is, if memory serves, the largest number of symmetrical faces possible for an isosahedron.
Oh, okay. It's a cool question, Sam.
Yeah, that was a thing that I looked up the other day and just remembered now, like, oh, that's a question I can ask you guys.
That's cool. I definitely
if a
didn't know.
If a photon never loses its energy, that means that every photon that was ever created still exists. Why aren't they all glowing? Why don't we see? Why isn't
They
everything
are.
illuminated all the time?
Okay, I've got a question for anyone who wants to ask it, because I was just looking on Twitter and
And how is a photon invisible? The visible light range different than a photon, say, in the ultraviolet?
Sorry?
Okay, I have a question. It's a bit different for everyone here. Someone can maybe answer. If God didn't create Yosemite Valley, how was it formed? Because this is something Answers in Genesis had just put out on Twitter, asking this very question. Any idea?
Isn't it part of the cauldron stuff with part of the super volcano cauldron?
No,
Caldera?
no, it's way
Cauldron.
further south.
Caldera, you
That's
dumbass.
Yosemite's in California, isn't
Is
it?
The Rocky Mountains have been formed and reformed at least 2 or 3 times in the Earth's history. That they've gone away, worn down to nothing, and then built back up because of the shift of the tectonic plates. The one that is running into California, running up its coast and stuff, is always present, always there, always pushing, and so the Rockies keep getting rebuilt. So it would have been created out of that tectonic plate movement.
Yeah, and it wasn't the valley itself formed via glacial movement, I think.
I don't know. I don't know if the glaciers got that far south.
Well, it says rock was formed on this seafloor from deposited silt, mud, and marine organisms, subsequently lifted above sea level, flexed into a mountain range summoned by a chain of volcanoes, much like today's Cascade Range. Granite that formed from molten rock to the roots of these volcanoes eventually remained at the core of the Sierra Nevada after the overlying sedimentary volcanic rock gradually weathered and eroded away. And they've got sort of artist interpretations of what I'm reading of 50 million years ago, 10 million years ago, 3 million years ago, to 1 million to 250,000 years, like 30,000 years. Let's put it this way: all of these things, except for the last one where they're estimating around roughly 10,000 years, pretty much all of them are way out of the range of what Answers in Genesis are willing to accept.
Yeah,
The age of
definitely.
the Earth.
It is volcanically based, isn't it? It's part of that caldera line.
Yeah.
Well, but that's what tectonics does. You get a plate that sublimates to the other, and the magma and stuff is mixing and moving and all that kind of stuff. It has to have somewhere to vent.
Sammy's asking Chad about Compton scattering.
We can ask. I could go with Seraphim's answer as well. Yosemite Sam formed it.
Yeah.
Actually, sod that. I'm going to fucking tweet that to AOG. Fuck them. Yeah, fuck them. Yeah.
And did Yosemite Sam use Acme stuff too, or was it just the coyote?
Yeah. He didn't, mainly the coyote, I think.
Yeah.
That's actually a good little gif here of Yosemite Sam with his guns to the floor going like bang, bang, bang. I'll just say he did this like thousands of times until the valley formed.
Yeah. Alright, do we have any more questions there? Shall we talk about the giant sandworms?
Sure.
Okay.
Although Kevin Bacon's not here.
So, these were found in ocean floor near Taiwan over 20 million years. Oh, well, they weren't found 20 million years ago. They existed 20 million years ago. They found the fossilized remains of these predatory worms that grew over 2 meters in length. They used to hunt other fish and things like that in the waters off Taiwan. Well, what is now Taiwan? Sorry?
How big are they?
Over 2 meters, so 2 yards.
Yeah, that's just a stinky 6 feet. That's giant.
That's a giant for a worm.
There's worms that big now.
Yeah, thin worms. So these are big. Yeah.
But there's worms that are 6 feet long now.
Are there? Aside from intestinal ones.
I'm sure I saw pictures. I think from Southeast Asia, somewhere. They look just like an earthworm, except they're like black and much bigger.
Oh, okay. I hadn't heard of ones this big before. That this was a bit of a thing. So, they also burrowed in the water, and the reasons these ones were preserved was because the burrows had collapsed on them, so they were trapped in the burrows, and we had a chance to. Because I mean, often worms
they
you don't
actual bodies.
I'm actually thinking that you could actually do a Stump some point, do a Stump Jen answers in Genesis version.
Oh, we could.
All the questions they ask, we could do that.
All right. How do they know the Earth is 6,000 years old? Why not 8,000?
Because they added up birth dates in the Bible. That's how they got it to 6,000.
Yeah,
all those
I've heard the
begats.
story of how this was done. Actually, I'm trying to remember who the name of the guy, but that did this sort of calculation of this by calculating from where they are to roughly where the ages and all that of all the biblical characters to get to roughly 6,000.
See, I find it really funny that the apologetic used to explain why that was not the case growing up was always that Hebrew genealogies only include notable figures. I don't know if that's actually true or not, but that's what I was always told growing up.
Okay, so I think Dog's question is more for you, even though he's addressed it to me. Other than battle, what was considered the most dangerous job in certain branch of the military during World War II? Depends how you're defining battle. Are you defining battle as foot soldier or?
The dangerous branch of the military. I see. I'm just trying to
espionage.
Look at this.
I would say paratrooper.
That's part now. But is that still battle?
Battle. Yeah, the question's not that well phrased there. I got to say, but
is spy considered battle because you're not actually physically
about people who are physically non-combatants? I just want them to clarify the question.
Yeah. If we're talking
I feel
physically
like if it uses
non-combatant, what about
non-combatant-
a field medic or a nurse?
Yeah, or possibly like plane pilots or whoever that were carrying. I just remember if troops were carried on airplanes at all during World War II. I'm shit at World War II history.
I mean, I like history. I'm not massively a World War II things. I mean, it's what I mean by except for battle is a little bit.
Yeah, if you're not, you
I'm
could be in battle
trying
but
to-
be a non-combatant. See, the question needs a bit more
Yeah,
context.
I mean,
As I
it's
said,
a little,
if you're a medic or a field
Yeah,
nurse or someone like that, you're in the middle of battle, but you're
Or
not fighting.
even if you were in like communications sort of thing,
Yeah, you could
that
be.
could be quite dangerous. Like if you're laying telephone wires or radios or whatever, could be quite bad. I mean, non-military, I'd possibly say merchant sailor was very.
Yeah.
That was very dangerous. Yes.
I mean,
No weapons.
yeah, I'm just kind of. I guess it's. I mean, I suppose for a combatant as well. I'd say if you're for a combatant, so not necessarily on the ground, I'd say the bull turret gunner in bombers was a pretty damn dangerous job. But I still would consider that as being in battle.
Yeah, see, that's the problem. I think if you're on the front, these aren't fighting soldiers, okay? So a non-combatant, but you might be in a dangerous area, then you're probably looking at a medical staff or...
I would
like you
say
said,
either that or people laying like telephone lines or something like that, and radio links could be a pretty dangerous job.
One of the most dangerous occupations in normal civilian life these days is lumberjack. Something we hardly ever think about.
Yeah.
It's just a deadly job, apparently.
Yeah.
So maybe in the army it's lumberjacks too.
Possibly.
Yeah.
See, I feel like
so this is
the
what
telephone
Royal
was sort of
Engineers.
pushed out.
Yeah.
Everybody talked over everybody else. Say again, Sammy.
I was saying I would have thought that the telephone layers was a decent shout actually.
Well, as Doug said in the chat, that would come like that. In at least that would come under engineering course, like in British Army, that come under the Royal Engineers, for example, as Doug pointed out. But I mean, maybe that's what the answer his answer is. I don't know, but
Night, Serapin.
It's because if he's saying it, unless he's dropping a hint there, because telephone communications would have been in the British Army, the job of the Royal Signals. So.
I wonder if...
He may have stumped me there. It's just that I'm not quite clear on the question, though. But I might accept that as a
didn't
stumping.
he answer it? So
I don't know if that was the answer or not. But
He said that it is a job in the Royal Engineers. I don't know if his answer is
communication repair engineer is the correct answer.
Communication. I was on the right. So I was on the right lines with communication. But yeah, I suppose I'll take that maybe as a stumping. But I was on the right lines
Demolition.
with communication.
Yeah, I mean, there's an awful lot of jobs that you could have had during the war that would have been put you close to the front lines without actually being a combatant. So, and that would have all been pretty dangerous to do.
Yeah.
And a rifle doesn't keep you from getting shot. It just gives you the option to shoot somebody else.
Yes.
So, for you, apparently, Jeff, what's the width of the largest fossilized tree stump ever found.
What? Oh,
I don't know why that's for
fossilized tree
you,
stump?
but hey,
Yeah, this is not my area.
it's not mine either.
Do we have
Yeah.
anyone who biology is their strong point here?
We have tree stumps that have grown large enough that that they cover several thousand years. So, and I've seen some pretty big trees too. So I mean, you could. You'd probably have had tree stumps that could be as wide as a car, easily. But
Well, sequoias are much
Yeah.
much larger than that.
yeah, you get some really big trees. So
Oh,
but
good.
they're
You
like
can get some
30, 40 feet in diameter.
yeah,
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 easily.
true.
Easily. Easily.
What dinosaur
Yeah.
is best at mimicking human speech? Which one of the
Barney.
birds?
Barney.
Barney. Oh dear, that's dreadful. I don't know which of the birds is the best at mimicking human speech.
I
think a
the
myna.
obvious answer feels like some sort of parrot, but besides African greys, I've never really interacted with birds that can mimic human
I mean,
speech.
even crows can imitate human speech. So,
True.
and magpies.
Crows.
So, I'm not sure which of the birds, but
Oh, I think Brainbug might have the answer in the.
corvids.
Well,
There you go.
corvids, which crows come under.
Yeah.
Crows,
So
ravens,
crows.
jays, mockingbird,
Yeah.
and a couple others.
Yeah.
Corvids are
I'm-
considered the most intelligent of bird species, and the crows and ravens being the top.
I'm still sticking with Barney though.
Fuck Barney.
Well, no
He
game, Jenny.
imitates human speech very well. He's a big purple dinosaur. He speaks.
Oh, apparently African grey parrots are considered the best talkers. So you have it, Sam.
Fair enough.
I like the fact that he
yeah,
was hoping
I
you'd
had-
trick us by saying dinosaurs.
Yeah, we all knew.
Well,
immediately.
you were on the right lines of birds anyway. So
Oh, we knew you meant
Yeah.
birds. Birds are dinosaurs.
Yeah.
Having
I was
said
going to say,
that, if you're talking about in
Have you
history,
ever-
we don't know.
But Jen, have you ever seen a Tyrannosaurus give birth to a seagull? I mean, that's stupid. That's just ridiculous. I can't do it as well as Ring does it. I mean, he's got.
Ring's got a link if he wants to hop in.
Yeah, Ring, come on in here because I gotta leave.
I
You
think
gotta go, do
possibly-
you, Jen?
No, I'm just getting really tired, and I need to get some sleep. I didn't sleep at all last
Well,
night.
I mean, we're not getting that many questions from the chat at the moment, and I'm also tired too, so I don't mind wrapping up if people have had enough. I've had fun doing this one. I don't mind having a shorter stream. I'm doing another stream tomorrow, so how about everybody have another go at shilling themselves out, because we've had a bit of fun here. So, Jeff, what you got coming up? Because you've got some interesting things.
Well, I've got obviously the usual things. So I should be doing the asterisk stream with Noodle. Could be interesting. I don't know if she's read the book yet, but I did warn her. I don't think she's going to like this one. So we'll see what happens when we'll see what happens tomorrow. I guess. I possibly will be on Ring's stream after that. Media Musings as I found out last week, I'm now an official co-host, thanks to you updating the intro, Chen. But Monday, I've got something interesting coming up. I have the African Humanist coming on for a chat at 7 p.m. UK time. So that's like 2 p.m. Eastern, I think.
Yeah.
That'll be probably past your bedtime, Jen, I'd imagine. But
Probably, but I'll catch it later.
yeah. I'm really looking forward to that conversation. She's a new creator in the community, and I think it's going to have a very different. It's going to have some interesting perspectives on like Christianity and like religion in Africa and so on. So I think that could be an interesting conversation. I think.
Cool. And Sam?
Sometime in the next week-ish, I have a video coming out, though I'm going to be not specific about it because I'm shit at coming up with names for stuff so far.
Should be good though, because your stuff's good. So we'll enjoy it. Jen, aside from sleep, what have you got coming up?
Nothing.
Nothing? Okay. Later today for people in the US and early morning for people in the UK and tomorrow morning for me, I'm doing a roundtable discussion where Will and I are going to grab in a few people and we're going to talk about Biden's first few days in office.
Oh, yeah. You invited me to that.
Yeah, I've invited you to that.
Yeah.
So that should be fun.
I'm disappointed because the pandemic's still here. He should have got taken care of that by now.
Oh, we'll have to talk about that. That was.
I know, right? We need to impeach him.
On Twitter, yeah.
Oh, dog! Don't ask a question like that during a Stump Jen. I honestly think that this was a dog's question about our gender traits completely a result of social expectations. This is a whole video on its own, and Sam and I had a discussion with Cheshevik about this earlier, and it was very interesting. And I'm thinking of teaming up with Sam and a few other people to actually have this discussion with other people, so we can talk about this, as well as other things. Yes, I know your hand will be up for that, Jen.
Yeah, my point of view on it is basically not entirely. Partially not entirely.
Basically not entirely, yeah.
I'll take the turf point of view.
Yeah. Oh, Chesh was actually very interesting because while she's supportive of trans people, she has a couple of ideas in her head that border in that direction. And it was interesting to have that discussion with her because she's not prejudiced either. So she has some of those gender critical ideas without actually being agenda critical. So it was made for an interesting discussion. Didn't it, Sam?
It did.
It did. So I'd like to have that discussion more with her because you know it's good to have somebody who's non-combative to actually talk about actual issues.
Oh yeah, and I've said to her if at some point she wants to have a chat with me about that stuff, I'm quite happy to discuss things some people might get upset about. Which was my reaction to her as well. I'm happy to have this discussion where we're not being combative, but we were actually just talking about it. So,
Sam, what was it like not being the youngest person on the stream yesterday? Because those Cheshire is 17 in perpetuity.
Oh, I forgot about that. Yeah.
Well, no. Apparently, according to Chesh, she's a 12-year-old boy. So.
Well, that was the thing, was it? Because Russian vids used like a transphobic slur at her one time, like he does. And he said, and Chesh said, "Yeah, okay. Which way am I transitioning then, Russian vids? Tell me." He rage quit.
So that's what's coming up. So if you want to see more of me and Jenny and Will tomorrow, hop on for a roundtable discussion, and we'll be talking about Biden's first few days, and at some point Sam and I will organise to have this other discussion if we can persuade Chesh to have it.
Sorry, I just read Doorknobhead's comment.
What did Doorknobhead say?
Grabbing a few people, Biden, was that accidental?
I hate you, Doorknobhead. No, I don't. Alright, so thank you.
Okay, we all hate Doorknobhead.
Yeah. You're as bad as Stool, Doorknobhead. Thank you everyone in the chat for joining us today. And thank you to all my guests. Thank you to Sam, Jenny, Jeff, and Chad. And I will catch you guys later. Bye.
Bye bye. See you in the comics.